Myself, Professor Ashish Chandak, welcomes you to Quick Engineering. The topic of today's video is construction of pushdown automata. So let us see the question. The question is design a pushdown automata for accepting a language L is equal to A raised to M, B raised to M, C raised to N, where M and N is greater than equal to 1. So if you observe this question, you will find A and B should be same and C is independent. So if value of M is equal to 1, N is equal to 2, then the string become A, B, C, C. If value of M is 2, N is 3, then the string become double A, double B, triple C. So C is independent. So we have to ensure that there should be equal number of A and equal number of B. So how to ensure it? So push down automata contains stack. So what we will do, we will insert one plate for A, and whenever there is occurrence of B, we will remove it. And then for C, since the C is independent, we will not do any operation. So there will be peep operation in the stack. So the logic is we for A we push the red plate into the stack. So we use red plate R, which is denoted by R, into the stack whenever there is occurrence of A, and for B we pop the red plate from the stack, and then for C whenever there is occurrence of C we will not perform any operation. So this is the logic. So first of all I will trace the logic and then I will write the transition. So here you will see there is tag, there is tape. I took the string double A, double B, triple C, and then followed by epsilon. So whenever there is occurrence of A, so we will insert some red plate. Okay. Since there are two A, so two red plate will be inserted here, and then whenever there is occurrence of B, so red plate will be deleted. Then for next B, again the red plate will be deleted, and then for C there will be no operation. Then for this C no operation. Then for this C no operation. But whenever there is epsilon, when there will be epsilon, this Z0 will be removed and the stack is empty. So string will be accepted. So in this way, the pushdown automata work. Now same thing we will write in form of transition. So let us see how to write the transition. So there are three input symbol A, B and C. So in pushdown automata, I will change the state only when input symbol get changed. So these are the transitions. So Q0 is the state, A is the input symbol, Z0 is the initial stack symbol. So Z0 is initial stack symbol. So pointer is here, and then this one here, the pointer will point here. So what is the operation? Operation is we have to perform insertion operation. So it is RZ0. So why RZ0? Because for A we are inserting red plate. So here I will write R. Then so this is the current state, this is the input symbol, this is the initial stack symbol is equal to next state, stack top symbol, and below there is another stack top symbol. So that is Z0. So Q0 becomes now next state become current state here. Again next input symbol, if you see the next input symbol is A, and then stack top is R is equal to Q0 RR. So this is transition or rule number 2. So again next R will be inserted for A. Now whenever there is occurrence of B, so Q0B and stack top is R. So what will happen? Since the input symbol is changed, the state will also change. I will write Q1 epsilon. It is 3. So then for next B, again I will write this next state become current state. Input symbol is R, stack top is R. Even though first R is removed, there is one more R. So that's why the stack top is R. So I will write Q1 epsilon. So this is 4. Now these two transitions are not same because there is difference in the state. Now next is C. So for C we have to perform no operation. So Q1 CR is equal to Q2. Sorry. Then this R will be removed since the symbol becomes Z0 Q2 Z0. So this is 5. Then Q2CZ0. Q2CZ0 is again Q2Z0. So this is transition number 6. Then for next C, you will find Q2CZ0 is equal to again Q2Z0. So since this transition is repeated, so there no need to write the transition again and again. Then you have to write Q2 epsilon Z0. Remaining thing is Q3 epsilon. So whenever you found Q3 epsilon, you have to stop. So these are the rules. This is how you have to write the transition for this push down automata. Then I will trace it for A, B, double C. So what is the use of validation? Validation ensure that your rules are correct. So I will take Q0, A, B, C, C, Z0. So what is Q0? A is the input symbol, Z0 is the stack top, is equal to Q0 VCC RZ0. So I have applied rule number 1, then Q0BR. Q0BR is Q1 epsilon. So it is Q1 CC Z0. So this is rule number 3. Then Q1C Z0 is Q2 C Z0. Okay. Then so this is rule number 5. Then Q2C Z0 is again Q2 Z0. So Q2 epsilon Z0. Now what is Q2 epsilon Z0 is Q3 epsilon. So this is the validation of the string ABCC, and this is how you have to validate the string and write the rules. So that's it for this video. If you like the video, then please subscribe, like and share. Thank you.